Okay, Assalamualaikum.
Okay, salam. Good
Good afternoon. Can you hear me?
Good afternoon, Adel. Can hear that?
Okay. Alright. Sekejap in each direction. Okay. The shortest path. Okay, sorry. Okay, the shortest path, which is fewest hopes from node 1 to node 6 is 136. Okay, so what happened? 1 direction from node, this is node 1, node 2, 3, 4, 5 and 6. Okay, so they have two techniques or two ways to calculate the paths from node 1 here to node 6. Number 1, they said the direction this arrow node 1, okay, see this direction. Can you see the mouse? Boleh nampak mouse tak? 1, okay, to 3. Okay, follow the direction, which is the cost is 5. And then from node 3 to node 6, the direction, the cost is 5. So 1, 3, 6. Okay, the nodes. Okay, so the cost is 5 plus 5, which is 6. Okay, another one, 5 plus 5 is 10 as well. 5, okay, the direction is 136, which is cost is 5 plus 5 equal to 10. However, okay, this one is the fewest hope. Maksudnya, fewer hopes mean nodes. Maknanya node yang paling sikit is 136. However, when we want to calculate the least cost, that means cost yang paling sikit sekali. Least cost pass is 1456. So what happened? 1456, 1, 4, 5, not 5 and not 6, which is follow the direction 1 plus 1 plus 2, which is 4 lah. Betul tak? Okay. Even though the node is longest, but the cost is shortest, which is 4 only. However, at first technique, which is node 1, node 3, node 6 is the less or fewer nodes. However, the cost is higher, which is 10. 5 plus 5, 10. So this is the way the algorithm calculate lah. Okay, the Chitra, we follow the least cost. Even though the hope is 4 nodes, but the cost is less. Okay, right. So, okay. Okay. Find table 1 and figure 2 show the results, okay, of applying this algorithm to the graph of figure 1 using s equal to 1. Okay. The shaded edges, shaded mean highlighted lah, define the spanning tree for the graph. Okay. So what happened? Okay, from this topology, okay. So if you want to calculate digital algorithm, have many steps. Okay, there's many steps. Okay, step number 1, they said the shaded edges or highlighted edges define the spanning tree. So this one, for example, the shade one, this one is spanning tree. Okay, the highlighted is spanning tree, the blue color. Okay, spanning tree. This one spanning tree, spanning tree, spanning tree, spanning tree. Okay. Okay, the value in each circle are the current estimate of Lx, L function of x. Okay, for each node x. Okay, so node x is a node lah, number of node lah. Okay, right. A node is shaded when it added to T. Okay, note that at each step, the pass. Okay, note that each step, the pass to each node plus the total cost of that pass is generated. Okay, after the final iteration, okay, the least cost pass to each node and the cost of that pass have been developed. Okay, so the calculation based on the iteration. Okay, iteration 1, 2, 3, and so on. Okay. Okay, the same procedure can be used with node 2 as source and so on. So that means we start from node 1. After that, go to node 2, node 3. So they have algorithm calculation. For example, so this is T equal to 1. Okay. So the T14, T124. That means T1245, T12345, T equal to 1, 2, 3, 4, 5. So you follow the shade. Okay. So eventually, digital algorithm will develop this table. So the iteration 1, for example, if T equal to 1, the X is nodes, number of nodes, 2. So if the number of nodes is 2 and pass is 1, 2. Okay, this one when L, if X equal to 3, so you get 5, which is pass 1, 3. If L, X equal to 4, and pass is pass 1, 4, and so on lah. So eventually you will develop the table. Okay, this iteration 1, ITR mean iteration, blah blah blah. So you follow the graph. Okay. Okay, 1 is pass 1, 2, for example. Pass 1, 2. Okay. 5 is 1, 3. Okay, 1, 3. Okay. So on lah. So based on this one, based on this node lah. 1, 2, 3, 4, 5, 6. Okay. This one I leave it to you lah to calculate, because to calculate it take long. You need to calculate one by one. Okay, based on this table. Okay. This one we will during tutorial we explain more detail. Okay. Right. Link state algorithm. Okay. Link state algorithm, which is digital. Okay. The basic idea is two-step procedure. Okay. Each source node, okay, get a map of all nodes and link matrix, which is link state of the entire network. So first step, that means when the packet is transmit, okay, send. So for the link state algorithm, they need to have the whole picture. Okay, and then after that, the shortest parts on the map from the source node to a destination node. So the map means this one lah, the whole node lah, the whole topology. Okay, this is the step. This is the universal statement for link state algorithm lah. Okay. Broadcast of link state information. Every node I in the network broadcast to every other node in the network. So each of the node must broadcast. Network broadcast. So what is the content of the broadcast? First is ID of neighbors, which is n equal to set of neighbor of I. Okay, I mean nodes lah. Okay, node I. Okay, distances of a neighbor. Okay, so the symbol is Cij. I is your nodes lah. Okay, J subset to Ni. Okay, flooding is a popular method of broadcast packet. So for link stack algorithm, the tactic to discover the network, they must flood all the packet, flooding all the packet through the broadcasting. Okay, right. So okay, digital algorithm finding shorter paths in order. So in summarize, okay, so this is the what we call how the algorithm works lah. Okay, so you have okay, find shortest path from the source to all other destination. So S is source, so this is your destination. W okay, you look at the green color. The green color first broadcast to W. After that W I don't know what we call this, dash one lah, and then double dash, and then broadcast again to X mark. Okay, after that X broadcast to Z and broadcast to Z minus. This is the universal algorithm ni lah, macam formula dia lah. Okay, closest node to S is one hop away. Okay, second closest node to S is one hop away from SOW dash, and third closest node to S is one hop away from SWOX. So this is how it works lah. Okay. Okay. In other words, okay, N is set of node for which shortest paths already found. Okay. Then this is algorithm. After that, okay, initialization, which is start with source node to S, which is N equal to set to S, D equal to 0. Okay, S is distance 0 from self lah, of course lah. Okay, D equal to C for all G not equal to S. Okay, distances of directly connected neighbor. Okay, step A, okay, find next closest node I, find I and such that Di equal to minimum Dj. Okay, I is actually is node, J is the neighbor lah. Okay, add I to N, that means N is number of nodes. So every time I is increasing, for example 1, 2, 3, 4. So N also will be added lah, increase as well. If N contains all the stop, so eventually let's say your topology have 10 nodes. So until N equal to 10, it will stop lah. Okay. Okay, step B, update minimum cost. Okay, this one you want to find the number of nodes. Okay, this one, step B is you want to find the minimum cost. Minimum cost mean the shortest paths lah. So for each node J not equal to N, so Dj equal to J is actually is cost. Minimum Dj D plus C go to step A. So this is what we call step 4 algorithm lah. Okay. This is another example lah. Okay, this example digital algorithm. This is another method. Okay, this is another method to calculate. So let's say you have node 1, 2, 3, node 3, node 4. The green color is okay, node 1 to node 6. Okay, step by step, N equal to 1, N subset to 1, 3, okay, 1, 3, 1, 2, 3, and so on. Okay. So this is when you do this link. So this is the steps. Okay, step how algorithm being calculated. Okay. Okay. Right. OSPF overview. Okay, you already know about digital algorithm. Okay, digital algorithm actually is the mathematician. The name of mathematician is Dijkstra. If I'm not mistaken, Dijkstra is from Netherlands. Okay, he's a Dutch mean orang Belanda lah. Okay. He is invented Dijkstra I think around 1930, 1940, something like that. 1940, 1930. Mathematician. And then now he invented Dijkstra algorithm. So what happened in our router, we use Dijkstra algorithm to apply at protocol that we call it as OSPF. OSPF mean open shortest path first. Okay, this is link state. Okay, Dijkstra algorithm sometimes we call link state algorithm. Okay. Okay, so what happened? OSPF, they will flood link state advertisement. Okay, link state advertisement to all OSPF router in the area, not just directly connected router. So what happened? Here you have 6 nodes. Okay, all routers in nodes need to configure as OSPF protocol, routing protocol. They say one of the router you configure different protocol, they cannot read. Okay, for example, you have Cisco router, you configure link node 1, node 2, node 3, 4, 5, and 6. So all the router, they will learn. So what happened? They will flood the LSA, link state advertisement. All router, okay? So next, propagate link state advertisement rather than routing table update. So what happened? To reduce the CPU processor inside the router, the OSPF protocol, they not advertise all the information. So what happened? They advertise link state advertisement first. That means basic information. Okay, so rather than you propagate the table update. So table update kan banyak. And so if you flood all the table, so the CPU utilization will be high. So you use CPU power will be 100% lah. And so what happened inside the LSA is only link, which is router interface, and state. Description of the interface and its relationship to the neighbor router. So this information only. Okay. Okay. Next, create a neighbor relationship by exchanging hello packet. Okay. So after that, when source, that means from node 1 to node 2. So node 2 is neighbor. So they will exchange the hello packet first. Okay. Okay. Pieces together all the LSA generated by the OSPF router to create the OSPF link state database. Next step, when they discover the next home, which is configured as OSPF router, they will develop OSPF link state database. Okay, use the short path first algorithm to calculate the shortest path to each destination and place it in the routing table. Okay. Okay. So now we need to know the top terminology lah. Okay, terminology in OSPF routing protocol. Okay, so peers. Okay, OSPF array. What is that? Okay, you look at this diagram. Cloud area 0, cloud area 1, and cloud area 2. And each of the cloud, for example, area 0, you have router 1 and router 4. Okay, and in area 1, you have router 5 and R2, router 2, they have 2 area 0 and area 1. Okay, this one, tengah-tengah ni, center. For area 2, they have router 6 and also except for router 2, router 2, router 3, router 4, they have 2 areas, which is for router 2, they have area 0 and area 1. Router 3, they have area 0 and area 2. Router 4, they have area 0 and BGP. This BGP is external routing domain, normally BGP lah, which is goes to internet. Right. So next, okay, link state routing require a hierarchical network structure. So the basic specification for link state routing is a hierarchical network structure. Dia macam tree lah. Okay, they must be hierarchical. Okay, area 0 here, for example, is the highest area, which is ibu dia, the main. Okay, this two-level hierarchy cause of the following. Okay, transit area, which is okay, area 0 normally we call it as a backbone. Okay, backbone. Area 0 is backbone lah. Okay, normal area, which is non-backbone area. So in this case, area 0 is backbone, area 1, area 2 is non-backbone. That means normal areas. Okay. Okay. So this is okay. Since OSPF is hierarchical routing, okay. So what happen is consists of the requirement is to reduce the routing update traffic, so that is not congested lah. Okay. Okay. Right. So areas, terminology and router. Okay. Okay. This one is the topology with abbreviation. Okay. You look at this sekejap. Okay, so sorry the interruption. Okay, so what happened? Okay, ABR. You look at this graph. Area 0. Diagram. You have area 0, area 1, area 2. Okay. Okay, so what happened? ABR, area border router. Okay, this one ABR. Area area border router normally you have two areas, either area 0 or area 1 or any number lah. Okay, area 100, area 200. So we call area border router. Okay, and then one we call ASBR, autonomous system boundary router. Okay, when you said boundary router, that means you must normally have two protocol. One is OSPF, maybe another one is BGP, IGRP ke IS. Normally is BGP. Okay? BGP version 4, which is internet. Okay, and then internal router. Okay, let's say inside the area 1. Okay, you have R5, router 5. This one we call internal router. So same goes to R6. Okay, R6 is also internal router. Okay, for area 0, just special for area 0, R1 known as backbone router. Okay, just for area 0 only. right? Okay. Okay. When you before you design your SPF routing protocol, you design the SPF. Let's say you are network engineer. You need to plan how to design the OSPF routing. Okay. So what you should do? What you should do first is you need to assess the requirement and option. Okay. What happened? Number one, you need to plan your IP uplink. Normally backup your data center in JB lah. Johor Bahru, sometime in Kulim high tech KTP Kulim Technology Park. Normally like that. Okay, and Sarawak in Kuching, in KK. For the industrial area, for the high population, your volume of population is very high. For example, like Penang, KL, okay, Klang Valley. So the utilization must be high lah. Maybe 200 tera, 300 terabit per second. If location in Kanga, you don't have to have high speed bandwidth lah. Maybe 100 gigabit per second is enough lah. Okay. After that, define the hierarchical network designs and areas. Okay. Evaluate the OSPF scaling option. Summarization where necessary. Prefix and define the stub area. So you look at this diagram, for example. Okay, core normally in Cyberjaya, or another one is maybe in JB, maybe in Penang, for example. Kulim. Okay, Penang. So area one maybe is kawasan tengah. That means Klang Valley, for example. Area 0 is maybe backbone lah. Backbone is cloud lah. Anywhere lah. The main nodes lah. Okay, area 0 maybe in Klang Valley. Okay, area 3 maybe in northern area. Okay, area 2 maybe in Sarawak area, and so on lah. So you need to design this way lah. Hierarchical and you need to assign the IP address plan. This one 10.1.0.0 is class A lah. It is a private IP address. So you need to assign all the router, and you need to define the ABR, ASBR. Okay, where is the stub? You need to design. Okay. OSPF function multi-area. Okay. High-level function or OSPF include the following. Okay. Discover, neighbor, and form of agency. Okay. Flood link state database. Okay, information. Compute the shortest path. Install routes in the routing forwarding table. Okay, additional function or SPF including detect changes in the link state. So any changes in the link state, for example, link state mean the router interface. Okay, router interface. For example, in router you have 0, 0, 1, 2, 3, 4, 5. For example, let's say in Ipoh the link is down. So it will detect any changes. So the SPF will be update all the database down. Maybe 4 seconds down, they cannot calculate. So database will change. Okay, several OSPF packet types are involved. Okay, this is the OSPF packet header format. Okay, so for its work. Okay, neighbor relationship, the hello packet. So hello packet, number one. So what is how it works? Let's say you have router 1, router 2, router 3, router 4, and router 5. Okay, so what happened? Router 1, okay, R1 will advertise the hello packet. What inside the hello packet? Okay, entry must match on neighbor router. Okay, number one, they have router ID information, hello and dead interval, neighbors, area ID, router priority, DR IP addresses, okay, backup database router IP address, and authentication password. Okay, stub area file. So this is information inside the hello packet. Okay, so neighboring agency. So what happened when hello packet arrived to the agency? mean the neighbor sebelah dia, the hello packet. What happened? The hello packet, for example, this is the authentication lah. Okay. Entry must match to neighbor router. So they have all the information and information must be matched throughout all the routers A, B, C, D, E, or R1, R2, R3, and so on. Okay, OSPF routing update packet. So this is packet number 2. Okay. Use multicast and unicast IP address. Okay. Okay. Link state database synchronization process. Okay. What happened? They will discover neighbor. Okay. Establish bidirectional communication. Okay. Elect a designated router. Oh, sorry. This one, DR is designated router. That means the root router. BDR is backup designated router. Okay. Designated router. If desired, form an agency, discover the neighbor routes, update and synchronize link state database. See, this is the process of database, link state database. Okay, establishing bidirectional communication. So what next? This dot 1, this is dot 2. So R1, this is Ethernet port lah. Ethernet port 0, this is Ethernet port 1. So that means it's a local area network lah. And then they have serial. Okay, serial connect to router 3, which is the Ethernet port will be 172.16.6.0/24. Okay, so what happened? The flow, first hello packet from R1 to R2, they will advertise. First, they will see the down state. Down state, that means the state. The link is down, okay? After that, okay, I'm a router ID with 172.16.5.1 and I see no one. If down state lah. And advertise, this is multicast IP address, which is 244.0.0.5. And then after that, inner state. So what happened? Router 2 here, a neighbor list, which is I 172.16.5.1/24, initial at interface E1, Ethernet 1. So acknowledgement, that means reply. So they reply, oh, I'm a router ID 172.16.5.2 and I see dot 1. Dot 1, this R1. So router and unicast. First multicast, after that reply unicast, which is router R1 neighbor list inside the database, which is .2/24 in interface Ethernet 0. Sorry, ini interface. Interface Ethernet 0, two-way state. So they have communication. That's mean establishing the bidirectional communication. After that, building the link state database. So after communication is happened, the next step they are building the database. What happened is, okay, in R1 they have a link state database R1. In R2 they have link state database R2. Okay, so the hello protocol is used to define neighbors. So R1 to R2 they are exchanging the communication and they find the neighbor. Okay, agency is established. That means neighbor tu dah established lah. Okay, adjacent router exchange link state advertisement. Okay, each router build an link state database using link state advertisement. Okay, so discovering the network routes. Okay, now after you have database, first you know your getting know your neighbor. After that, you build up your database. Now you want to discover the network routes, which is the shortest paths. Okay, something like that. Okay, so from R1 to R2 just now same. So X start state. Okay, so database said I will start exchange because I have router .1. Okay, at the router 2, database router 2. Okay, no, I will start exchange because I have higher router ID. Oh, so what happened in R2? They said I have a higher router ID, so I should be designated router to exchange state. Okay, here is summary of my link state database. Okay, after that, R1 exchange their database. They said here is a summary of my database. So this is the way how they are changing lah. Okay, adding the link state entries. Okay, so the next step, acknowledgement. So thanks for the information. For example, So each of the router exchange their link state entries. So next step, the loading state. Okay, I need the complete entry of the network 6.0/24. Okay, 6.0 is at the R3 because R2 connected to R3. So they want this R3 information. So they request. So what happened in router in database R2? Okay. So what happened is, here is the entry for the 6.0/24, which is belong to R3. Okay. After that, at router 1, LSA advertise or acknowledgement, which is, okay, thanks for the information. Okay. Full state communication. Okay. Flooding changes in topology. Okay. Okay. So, for example here, you have router 1, router 2, router 3, and you have designated router. Designated router is like your roots lah. Okay, root router. So you have LSU here. You mean updates. Okay, router 1, R1 that detect a topology changes, adjust link state advertisement and flood the link state A. So from R1, let's say R1, the link is down. So what happened? R1 detect changes lah. Okay, so we will advertise all the LSA. Okay, LSA which is update lah, link state update lah. Okay, router 1 notify all OSPF neighbor using multicast 224.0.0.5. This is a multicast. This is a standard IP for multicast for OSPF neighboring update. And then LAN local area network links all OSPF designated router and backup designated router using 224.0.0.6. Okay. The designated router notify other which 224.0.0.5. Okay, acknowledgement again. The database for all router must be synchronized. So what happened? Let's say this down, one down, they will advertise the LSA. 1, 2, 3, 4. This is the update lah. So I need to update my routing table. So again, they will using this IP address .5.6. Okay. Okay, link state data structure, link state operation. This is the operation of link state advertisement, same as what I already mentioned to you. So this is the flow of flowchart. Okay, so entry database, add the database, link state management, flood, and so on. Same thing. Okay, link state advertisement also have many types. They have, I think, 11 types. Okay, so LSA type 1 main router LSA, LSA type 2 is network, 3 and 4 is summary, LSA 5 is autonomous system and external LSA, LSA 6 is multicast OSPF, 7 for LSA defined and not stubby areas, type 8 is external attribute link state advertisement for BGP. Sorry, 9, 10, 11 is opaque LSA. So this is LSA type. So not only one, they have many type. Okay, I think, okay, this for LSA type 1. So what happened, type 1, one router LSA for every router in area, inter-area. So type 1, they do like this. Okay, no for internal router lah. Okay, type 2 is a network LSA, is like this one. Okay, one network for LSA. They're known as non-broadcast multi-access. Type 3. Okay, type 4. Okay, sorry, type 3 is like this one. Normally multi-area. Okay. Type 4, border router. Okay, using border router, which is here this one. So this one ABR, they will advertise type 4. So based depending on the topology and the area type. Okay. Okay. I think the rest too many. Okay. Not so important lah. Okay. So I think that's all. Can you hear me? Okay. Okay, for Friday, because Friday I think we do online as well lah. Because I have meeting around 9:30 a.m. So we start at 8:30 sharp until 9:30 lah. Okay, 9:30 a.m. Friday. Betul kan? Kita ada kelas Friday kan? Hello.
Ada.
Dengar tak?
Friday ada kelas ada.
Okay. So actually our class should be finish at 10, right? But we make it 1 hour lah. 8:30 until 9:30 lah. Okay, for the next I think last Friday. Okay, Friday is maybe my last class lah. Okay, but remember we have test 1. We have test 1. Okay, I will discuss with Hazim. When should we do test 1? Maybe next week ke Saturday, Sunday. But we need to do what we call face to face. Okay, cannot do online. So face to face. I will discuss with Azim. After that, we will inform you when the date. Boleh? Dengar tak?
Ya Dato', boleh. Boleh Dato'.
Azim ada tak? Dia datang tak? Azim, are you here?
Ada.
Azim, ada? I will discuss you later, okay? Okay, thank you everybody. Assalamualaikum.
Doktor.
Thank you, Dato'.